Friends, how are you all? Welcome to the class. Students, today we will continue the chapter is matter around the sphere. So, we will discuss the first one is Tyndall Effect. So, what is Tyndall Effect actually? When an intense converging beam of light that is passed through the colloidal solution. Okay, it kept in dark, the path of beam get illuminated, and this phenomenon is called the Tyndall effect. So the Tyndall effect is due to the scattering of light by colloidal particles. Okay, you know solution, suspension and colloids. So you have to learn the definitions of that solution, suspension and colloids and their particle size also. Okay. So this one is the Tyndall effect, and Tyndall effect may be defined as the scattering of light by colloidal particle present in the colloidal solution. Here you are seeing that beam of light is passing here, and that beam of light here you are seeing that it is not visible inside the true solution, and true solution sugar solution is here. So the particles in true solution don't scatter light. Due to this we cannot see the path of beam light inside the true solution in beaker. Here you are seeing, but the particle in a colloidal solution there is the more particle size in comparison to that true solution, and you are finding here the particles in colloidal solution it scatter the beam of light. Okay. Now next one is character of true solution, colloidal solution and suspension. It is very important. So particle size is most important, that is less than 1 nanometer in true solution, but that is 1 to 100 nanometer in, and it is invisible. Okay, and more than 100 nanometer visible in naked eyes. So solution, suspension and colloid, this one is the particle size about that. And nature, so true solutions are homogeneous, and here these both are heterogeneous. Now setting up particles, you know particles don't settle down into the true solution, but here in case of colloidal solution particles they don't settle, and particles settle on standing here in this case. Okay. Now next one is separating of the component and a mixture. It is very important thing. So students, first one is evaporation. You know what is evaporation? You had studied about the evaporation in previous classes. So evaporation is a process of change of liquid into vapor state, and when it is done, when it find the temperature. Okay, and here you are seeing that the color component dye can be separated from blue ink by this method. Which method? That is evaporation method. Okay, you are seeing here. Now centrifugation, it is very important. By this method you find the cream with the milk. So centrifugation is the process where a mixture is separated through spinning, and imagine a mixture where there are two different sizes particles. If you here leave this mixture over the time of large particles would settle here to the bottom, but it will take long time. And centrifugation used a device which is called a centrifuge that can rapidly spin to speed up this process, and it is used to separate the skimmed milk from whole milk, and water from your clots, and blood cells from your blood plasma. In these processes this centrifugation is used. Now next one is students sublimation. It is very important. Sublimation means direct change of solid into gas without changing into liquids. This process is called the sublimation. So sublimation is the process in which there is direct change of solid into gas on heating without changing into liquids. This is found into the, you can say that, for example, ammonium chloride, camphor, etc., naphthalene ball also. So here next one is chromatography. So chromatography is a technique for the separation of mixture, and the mixture is dissolved in a fluid that is called the mobile phase. Okay, which carries it through a structural holding and another material called the stationary phase. So one phase and one is stationary phase, and chroma is a Greek word, it means the color. So here this technique was first used for the separation of color, so that it is called the chromatography. Okay. Now you are seeing here the dye is black ink of a single color. You will prove it here with the help of this example, and this activity is given here. And the application of chromatography, it is used to separate the color in a dye and drugs from blood and pigments from natural colors. Next one is distillation, students. In a mixtures, sometimes liquid and miscible which boils without decomposition and have sufficient difference in their boiling points. Such components can be separated by distillation. Now distillation is the process of separating of components from a liquid mixture by selecting boiling point. That means few elements, suppose that the compounds which are mixed, they have different boiling point. So at their boiling point they will separate very easily. This process is called the distillation. Okay. Now students, you are seeing here fractional distillation. So what will you find in fractional distillation? To separate a mixture of two more miscible liquids for which is the difference in boiling point is less than 25 K, 25 Kelvin. Okay. Now fractional distillation process is used in that situation, and fractional distillation is the process of separating of a mixture of chemical compounds. Thus it means that each part called the fraction of the mixture, and it can be kept apart from the other chemicals. Okay. So different chemicals have different boiling points, I have already told you, and the fractional distillation, it is done by heating the mixture so that each fraction evaporates at their boiling point. Okay. And then condense when here they evaporates, and fractional distillation is done by heating the mixture so that each fraction means that component at their boiling point that evaporates and then condense in its own compartment. Okay. And petroleum is refined by the fractional distillation. It is very important. So you are seeing here the fractional distillation, and how can we obtain different gases from air. This process is separation of air, component of air is most important. This is very important, that how will you separate the component of airs. Okay. So air component will be separated here, so you will use this diagram also. I think this is sufficient for today, and remaining portion of this chapter we will discuss in our next video, students. Till then, thank you everyone.